They are the monsters of the deep blue sea. Giants that help keep our modern world going. They are supertankers. They carry LNG, liquid natural gas. Building a supertanker and keeping its cargo safe is the ultimate engineering challenge. For the energy content of ships like this is the same as 60 Hiroshima bombs. To make these huge vessels safe will take precise engineering and super science. Only when every part of the boat is right will it take its place alongside other supertankers as a megastructure of the sea. Our supertanker journey starts here, South Korea, a country that produces 75% of the world's LNG supertankers. It's a highly competitive business. One of the industry leaders is Samsung, better known for electronics. They also have a division at the forefront of supertanker design and engineering. Their mission is simple: to get as many boats built as quickly and as safely as possible. Deadlines are getting tougher. Demand for energy is increasing daily. These fuel-carrying giants play a vital role in keeping our modern world going.
LNG supertankers are really right there at the top of the list in terms of technology. They're some of the largest vessels, and of course that makes them very interesting in terms of engineering.
The birth of Samsung's latest LNG supertanker starts here in the docks. Ordered by a Malaysian corporation, she will be named Seri Amana, which means royal honour and trust. Her construction will be complex and relentless. Every inch of the shipyard's 3 million square metres will be used to build her. The reality of this industry is that time is money. Any mistakes or delays can cause costs to spiral out of control. Supertankers like this can sell for more than $200 million US. So the quicker they are built, the more money there is to make. Building a supertanker is done in specific stages. The boat is divided into 6 huge sections called megablocks that can weigh up to 3,000 tons. Each megablock is built independently from smaller blocks. These can weigh up to 1,000 tons. Once each megablock is complete, they are welded together to form the supertanker shell. The interior of the supertanker is outfitted with 4 massive insulated cargo tanks designed to carry liquid natural gas. An enormous engine is installed with pipes to transport the LNG on and off the ship. Finally, the crew quarters and bridge are put in place. Quite simply, the build starts small and gets bigger. Completed, our supertanker will be 282 metres long, 33 metres high and 42 metres wide, and weigh 75,000 tons. Samsung shipyard is the second biggest in the world. Everything to do with it is huge. In a year, it takes delivery of 900,000 tons of steel. Over 3,000 kilograms of rice is consumed by the 20,000 workforce every day, and 1 million man-hours will be needed to complete Supertanker Seri Amana. The first shift starts at 7:30 a.m. sharp, and the workers head toward their designated sections spread over the shipyard.
One of the most impressive things when you walk into a Korean shipyard is the size, particularly, the ones that are building these large LNG tankers. There are large blocks sitting all around parts of many ships throughout the yard, very orderly setup. Just to see the level of work that's going on in these places is incredible.
The first phase of Supertanker Seri Amana's construction journey is the steel preparation and cutting. A barge arrives with large pieces of untreated steel. Each weighs 6 tons, more weight than 2 New York cabs. 4,000 steel plates like this will be welded together to make our Supertanker's hull. It is the start of a relentless year and a half of hard labour that will turn her from a single plate of steel to a giant supertanker. Each sheet has to measure up to exact specifications. The steel must be 2 centimetres thick, 14 metres long and 4 metres wide. Only when this technician is happy the steel is of the right dimensions can it be sent to be cleaned and treated. There is no time to waste. Tight deadlines mean this steel is needed now. Without a constant supply, the shipyard would fall quiet. This worker is in charge of transforming the raw steel into a shell tough enough for a supertanker. First, powerful jets of water blast off any rust and dirt. Next step, a furnace. The aim, to get the steel to a uniform temperature for the next stage, shot blasting. In here, thousands of tiny fragments are fired at the steel. This gets rid of any imperfections and impurities. After this, the steel is coated with an inorganic zinc silicate primer. This protects the steel whilst it's being worked on and releases less toxins during the cutting process. The steel plate is now primed for action. It has one last check. Even at this early build stage, the team know this steel plate's destiny. It, alongside 4,000 others, will be dispatched all over the massive shipyard, where a small army of workers, robots and cranes will work flat out to mould steel plates like this into sections that over months will finally begin to resemble parts of a supertanker. Every single member of the team needs to be focused. Any mistake can put the project behind schedule, over budget, and potentially jeopardize the boat's safety. One weak piece of welding or cutting can make parts of the supertanker vulnerable. Something you can ill afford with a volatile cargo like liquid natural gas. In 1944, an entire square mile of Cleveland was leveled when an LNG storage tank exploded, killing more than 130 people and leaving hundreds homeless. Survivors described this scene of destruction as looking like a war zone. Energy is vital for life on our planet. Imagine a world where cars stop, cities face blackout, and factories cease production. Supertankers carry Earth's very lifeblood across oceans to faraway continents. But with oil reserves running out, the world is searching for new fuel sources and new ways to transport them. An answer is liquid natural gas, and the vessel to carry it, LNG supertankers. Demand has soared from 56 million tonnes per year 10 years ago to a staggering 130 million tonnes in 2005. Some experts predict this will triple in the next 10 to 15 years, presenting a serious problem. There are not enough LNG carriers to cope with the demand. Natural gas is found in gas fields all around the world. It is drilled for on land or at sea and transported to liquefaction plants via pipeline, where it is condensed into liquid form at a temperature of minus 160 degrees Celsius. Once in a liquid state, supertankers can transport it across the globe to be offloaded at regasification plants where the LNG is returned to its natural state. It is then delivered via pipeline to factories and homes. It's a high-tech operation needing high-tech transportation. But to float and power a ship bigger than the Titanic is a design challenge. Workers and technicians in the shipyard are dependent on the engineers in the research lab to give them the most effective plans for the supertanker. Only when the engineers are confident that the designs will work, will the information be sent to the shop floor, where skilled workers make sure the metal plates end up ship-shape. Every plate must be millimetre accurate. Only then can the plate be sent to the next construction phase. The steel cutting and fabrication is done in this massive hangar. 73 cranes, 11 robots, and 1,000 workers are all assigned specific tasks to get the Serie Amana into shape. It's a relentless operation, requiring accuracy and concentration. Every worker and every machine has a crucial role to play.
They're methodical, they're experienced, and they're following, sets of procedures that have been set up in order to do this diligently, properly, and as quickly as possible.
These are the first pieces of supertanker Serie Amana to be cut. Precise information from the blueprints is transferred to the factory floor, where skilled technicians oversee robots cutting to the design dimensions. The robots cut through plates of steel at temperatures of 3,500 degrees Celsius. Each piece a vital part of our supertanker jigsaw.
Accuracy is important. There are quality controls that are placed on the construction of the vessel. If something's not done within those parameters, normally it has to be redone.
Only when the technicians are convinced the task is completely accurate will the steel be sent on to the welding section, where they will be joined together and become bigger and bigger, evolving into a new generation of fuel carriers that carry liquid natural gas. Designed for a specific part. 98 of these will be joined together in 6 mega blocks to form Seriamana's hull. Transporting these huge sections around requires some big machines, like these specially designed flatbed vehicles that can support 1,000 tons of steel. Getting these blocks in the right place at the right time requires even more serious lifting gear, like these mega cranes. Without these giants, the whole shipyard would grind to a halt. Being a crane operator is one of the most stressful jobs in the shipyard, demanding 100% concentration. Safety is paramount. Any mistakes could be fatal. So to avoid the risk of burnout and errors, operators only work in 4-hour shifts. This block is part of our supertanker's hull and weighs an incredible 500 tons, more than a jumbo jet airliner. On the ground, safety officers make sure no workers are underneath it.
Safety is paramount. There's a lot going on. There's a lot of big, heavy equipment moving around. You have to keep your wits about you.
The block needs to be moved as quickly as possible. The longer it's airborne, the more delays to traffic on the ground, slowing down the whole shipyard. But this never gets in the way of safety. Every worker knows just how dangerous manoeuvring a weight this size can be. So if a safety officer tells you to keep your distance, you do it. This area of the shipyard is now ready to resume activity. This huge section is just a small component of Serie Amana. It needs welding to other erection blocks, eventually becoming a mega block. Six mega blocks will make up Serie Amana. They are huge cross sections of the ship built and outfitted separately. This mega block is the stern or back end of the boat. Staircases and a network of pipes are already taking shape. Inside, a team of workers are busy outfitting the interior. Eventually, this section will be welded to another mega block. But getting these 6 giant sections together is one of the most challenging and potentially dangerous parts of the entire build. Supertanker Serie Amana is 6 months into her 18-month construction period. She's approaching a crucial stage, the dry dock build phase. All 6 mega blocks need to be lifted into this dock to be welded together.
Most of these projects will have critical paths, right? Which means that one particular item has to be finished before another one does.
Waiting on the other side of the shipyard is the rear or stern section, all 3,000 tons of it. Too heavy for cranes like this, but not for sea cranes like this. They can lift an incredible 3,600 tons, but this kind of muscle does not come cheap. Using one costs $30,000 a day. But today, there is a big problem. High winds. It's too risky to lift the mega block. Each of the crane's cables is designated an exact load. If a gust of wind creates too much movement, the weight fluctuates, which could snap the cable. And if one goes, they could all go, risking the lives of workers on the ground and on the sea crane. This is an expensive setback for Samsung, because it still has to pay for the sea crane. Even worse, it means the next phase of construction in the dry dock cannot go ahead as planned. The safety officer carefully monitors the conditions. There is a slight drop in the wind, but the operation is halted. With the stakes too high, the liftoff is called off. For the first time, Serie Amana is behind schedule. Dawn, the following day. The weather forecast for later is bad, but at the moment conditions are deemed safe enough for a mega lift. But there is a new challenge. This giant structure needs to go to dry dock number 2, over a kilometre away. This procedure normally takes a minimum of 3 hours. But because the build is behind schedule and the afternoon's weather forecast is bad, the team decide to try and move the mega block in record time. On the ground, workers knock out the huge steel struts that support the mega block's 3,000 tons. On the sea crane, the operators check that all the cables are in place and that the huge weight is displaced safely. Finally, it's time for liftoff. The mega block, designed for the sea, is airborne. The operator maneuvers this colossal structure over the water. Tugboats push it towards the dry dock. Any rogue gust of wind or mechanical error could spell disaster and cost millions. The whole shipyard is caught up in this record mega lift attempt. The stern is now meters away from the dock, but this is where the pressure kicks in. The crane operator has to align it to within centimeters of the rest of the hull. Too big a gap and they can't be welded together, meaning further delays. Something the company cannot afford. In the dry dock, safety inspectors and engineers ensure everything is in place for the sea crane operator to lower the mega block into position. Slowly, the block is lowered. Finally, it's put down and is millimeter perfect. "3,000 tons moved 1 kilometre in less than 1 hour. A record. And within minutes the process of welding the mega blocks to the rest of the hull starts. Supertanker's Serie Amana is back on schedule. Workers flood the dry dock. It will take 150 million litres of water before Serie Amana can be tugged out, enough to fill 60 Olympic-sized swimming pools. The following morning, for the first time in her life, Serie Amana has been touched by the sea. The tugboats remove the dry dock walls. Safety officers check that this huge vessel is fit for launching. The tug pilot ensures all lines are secure. final checks are complete, Seriamana takes to the water. Even though the tugboats are 100 times smaller, they still manage to pull the supertanker out of the dry dock. An impressive and imposing sight. Supertanker Seriamana is now quayside and ready for the most important part of its build, the 4 massive cargo tanks which will contain the liquid natural gas. Inside her hull, workers have erected over 5,000 tons of scaffolding. This huge space is one of 4 cargo tanks that will store LNG at a temperature of minus 160 degrees Celsius, ensuring the gas is condensed in liquid form. This tank has over a 42,000 cubic metre capacity, enough to power a city the size of Washington, D.C. for a day. Storing the gas in liquid form means you can carry more of it, making these supertankers more economical and more profitable by carrying large quantities of fuel to clients. If natural gas was not stored in a liquid state, a supertanker would need to be 600 times bigger, making it 177 kilometres long in order to carry the same amount of fuel. An impossible size for harbours to accommodate, let alone build. Keeping this precious liquid cargo secure during voyages means developing cargo tanks that are totally secure.
There are certain features of LNG that pose dangers to the vessel. The low temperature of the LNG would pose a danger to the ship's structure, the steel, if it were to come into contact with it. And also there's a flammability and explosion risk from the gas itself. So the containment system is set up and designed to mitigate these things and to control it.
Every millimetre of the tank's 42,000 cubic metre interior has to be insulated. Contact with the freezing liquid natural gas could weaken the inner and outer hull, leaving the whole ship vulnerable. The outer hull offers the first layer of protection. Then next to the inner hull, polyurethane foam insulation. Then a secondary barrier, more polyurethane foam, followed by a layer of wood, and the most vital part, a stainless steel membrane. Stainless steel is more resilient at low temperatures and less likely to corrode.
It's similar to a thermos flask. It's intended to maintain the temperature of the cargo, which is how you keep it in its liquid form.
So workers must ensure that the whole of the cargo tanks are covered in stainless steel. A tiny hairline gap could jeopardise everything. Because the safety stakes are so high, welding has to be accurate. The shipyard employs expert welders and have developed a new range of robots. Using a laser to work out where it is and what it needs to do, the Spider robot precisely welds together some of the 2,000 individual plates that make the stainless steel membrane, helping to ensure the cargo is contained. But that's not the only safety measure.
These cargo tanks are huge, some 45 metres long, 40 metres wide. And as the ship is moving in the seaway, you get huge waves building up inside the cargo tanks. So the actual containment system has to be really strong to be able to withstand these forces that are punching against it and trying to dislodge it.
Any miscalculation could cause dangerous inertial forces to be generated by the millions of gallons of liquid shifting violently. All over the cargo tanks, workers are installing sophisticated monitoring sensors that relay the cargo tank conditions. This information will be watched 24/7 on every voyage. It takes over 9 months to install, test and safety-proof all 4 cargo tanks. Work is nearly completed on cargo tank number 3. The scaffolding is removed, and in the depths of the tanker, the insulation is checked for damage and cleaned. Higher up, welders and robots work together to ensure every part of the cargo tank is perfect. After thousands of man-hours, it is unveiled in all its glory. When these tanks are fully laden with LNG, Supertanker Serie Mana will weigh 125,000 tons. Hauling this massive weight demands a lot of power. In this section, work is being done on the engine room. A team of specialists are busy outfitting the area. Carefully, they check that all the components have been built to the right specifications. The final stages of welding and finishing work are on schedule. Safety inspectors double-check every centimetre to detect any faults. This enormous space will be the heartbeat of our supertanker. Even though she is a flagship packed with 21st century science and technology, she will actually be powered by a giant steam turbine. In this 270-ton boiler, water will be heated to 500 degrees Celsius. The superheated steam will then rotate the turbine that drives this massive propeller. Serie Mana is now just a month away from her scheduled delivery date. The pressure is intense. If any flaws are found, they will have to be corrected, delaying the contract being signed and final payment. She will only need a crew of 40 to operate her. This supertanker is no longer the scarred steel fortress she was a few months ago. Now she is painted. Throughout the ship, a 39-kilometre lattice of pipes has taken shape that will transport the LNG on and off the ship. The engine room has gone from this to this, pristine and ready for action. This is the finished boiler that will power Serie Mana across the ocean. The turbine is installed. This will be the driving force and weighs in at 293 tons. The accommodation block and bridge are also ready. On the high seas, the crew will not be slumming it. They will all have ensuite bedrooms, and the ship is equipped with a games room, and an elevator. There is a modern kitchen with a gourmet chef serving up quality food for the captain, his officers and the crew. But Serie Amana is not a luxury cruise liner. These 40 officers and crew are all part of a team in charge of making sure this enormous vessel will cross huge stretches of waters safely and on time, delivering liquid natural gas to a growing number of clients. It's a tall order, especially for the captain.
As captain of the ship, you've got an awful lot of responsibility. I suppose you have to be a pessimistic person. You have to look upon what's the worst that could happen and then act in advance of that happening. You make no sacrifices. Everything is about safety on an LNG carrier.
As state-of-the-art navigational and warning devices which track any vessel in the vicinity and let the nearest port authority and Coast Guard know their exact location.
Alright, thank you. Alright, it's all ready?
Sophisticated radar like these also detect any threats. LNG supertankers like Serie Amana can be potential targets for modern-day pirates.
Much of my seagoing time was spent in the Far East, and there are areas around there where it is a risk. I'm talking piracy here. They call them pirates. Basically, the vast majority are just opportunist thieves, and what they want to do is to get on board the ship without being seen, take what valuables they can, get off as quickly as possible.
There is also another danger.
In these days, I think any ship is a terrorist target. Certainly in the LNG trade, we comply with the security code. Each ship has to develop its own security plan, which is adhered to. The main defence in LNGs is making sure that no other traffic comes close enough to the LNG carrier to cause a problem. Whether it's another cargo ship, whether it's a container ship, another tanker, or whether it's a small boat that shouldn't be there with other purposes.
Control, this is Sri Amana, calling your channel 16.
If there is a perceived threat, an officer can use the ship's security alert system to send out a distress call. Another security measure is a network of closed-circuit television cameras that scan all of Serie Amana. The vessel is also checked by the crew for any security breaches. As the world's oceans become busier and busier, collisions are becoming more of a concern. This complex radar can detect boats over 193 kilometres away and track them. If the navigational officer believes they're heading for a collision, the other vessel will be asked to change its course. An LNG supertanker going at full speed takes 14 minutes to stop, so smaller vessels tend to get out of the way. It is essential that the captain and his crew familiarise themselves with every part of Serie Amana before they set sail. There will be several tests and detailed checks. It's only when these trials are completed that she will be ready to embark. It has taken a non-stop 18 months to turn supertanker Serie Amana from this to this. Over 4,000 plates of steel were used, 40 kilometres of pipes, 240 kilometres of wiring, and 330,000 litres of paint. She's 33 metres wide, 42 metres high, and 282 metres long. When she is fully laden with liquid natural gas, she will weigh 125,000 tons. Despite harsh weather conditions and tight schedule, Seriamana has passed inspection and is deemed seaworthy. The delivery contract is signed, something worth celebrating. On board the ship, the captain flies the Malaysian flag, indicating he is in command of Seriamana and that she is now an operational supertanker costing more than $200 million and clocking 1 million man-hours. Seriamana is now on her way to fill up her enormous cargo tanks with liquid natural gas and take her place alongside other supertankers as a mega structure of the sea.